Okay, you've all heard of pop quizzes. This is one. I have a couple of questions for you, 6 to be exact. Let's see how you do. Each question is going to be asked on a scale of strongly disagree to strongly agree. So think about where you might put an X on that continuum as I ask each question. Let's start with number 1. The primary purpose of risk communication is to reduce fear and panic. Strongly disagree, strongly agree. The answer would be strongly disagree. Sometimes you do have to increase fear, and panic is greatly overestimated. Second question is, the key to successful pre-event planning is to develop risk communication messages prior to a crisis. Strongly disagree or strongly agree? The answer might surprise you. It's a little to the right of strongly disagree, to the strongly disagree side of middle, and that's because there are often unique circumstances that you can't pre-package. An individual's perception of risk is based on an understanding of possible negative consequences. Here the X would go smack in the middle. It's true that the public responds more to consequences than they do to probability, so understanding consequences would affect the perception of risk. But it's also true that outrage factors matter more than hazard in many cases, and they might not be related to the negative consequences in any direct way at all. During a crisis, risk communication should be limited to the organization's official spokesperson. Here we would strongly disagree. In general, you want to use multiple channels of communication. During a high-stress situation, the spokesperson can help build trust and credibility by demonstrating human qualities such as caring and empathy. If you mark strongly agree, you're correct. The role of media during a crisis is to help the communicator deliver their message effectively. And here the answer would be strongly disagree. The media have their own motives and their own agenda, and it has no need to help the risk communicator deliver their message effectively. How'd you do? Okay, well then let's take a look at a new topic now. Quiz is over. In this video, we're going to talk about how you explain quantitative data to others, especially others who might not have quantitative backgrounds. When you talk about quantitative information with others, there are 3 things to remember: motivation, simplification, and orientation. Over the next several slides, we're going to take a turn unpacking each of these 3 ideas. When you go to a meeting, begin by asking, what are your questions? What do you want to know? Even before you begin your presentation, write them down so that everyone can see them. Then say, we're going to cover this and this in our presentation. Pointing to some other questions, you might say, we can make a point to discuss this afterward. And we're unprepared to discuss that question because we lack the information, so we'll have to get back to you. Write down the questions until they run out, then go through them and respond to them in a general way. Again, as I said, it's okay to say, this one we had not intended to talk about, but I can answer quickly. That one will take more time, let's add it to the end. This one we'll get back to you on, and apologize for the ones you cannot answer at all, but say that you can answer them. This is better than spending an hour on something no one's interested in. It makes the meeting feel more responsive. People come to meetings focused on their questions, and they worry that they'll forget it or look silly asking it, or be humiliated, and so they don't listen to you. They rehearse their question over and over. So if you go through the questions early, before you begin to talk, then people can breathe a sigh of relief and settle in and listen a little better. This all helps to reduce outrage, and it's the first step in motivation. Reduce outrage. When people are outraged, the numbers don't help or hurt. They have no effect at all. When people are outraged, how you explain the data is irrelevant. If you want to explain the data and have it be useful, first you have to lower the outrage. We want to get people to want to know the data. The main reason data do no good for outraged people is they are not interested in the data. They do not want to hear or believe the data. So it's the motivational factors that matter the most. To get people to want to know the data, first lower the outrage. Then share control. Give people a decision to make for themselves or their families based on the data, and then people will care about your data. If the decision is mine, I'm interested in information. If someone else is making the decision, I don't care about the information. So share power. Making the audience want to hear the data is more important than any particular skill in presenting it. The audience wants to understand the data because they have a viewpoint and they seek ammunition, or they face a decision and are looking for guidance. You're better off as a source if you can create the second circumstance. If you use data to coerce or corner people, they're going to be less interested in it. So if you use a risk comparison to enlighten someone and to help them understand the risk, to make a wiser decision, they're going to like it. But if the comparison is trying to corner them and make it harder and harder for them to find the risk intolerable, when they want to find it intolerable, they're going to need to reject the comparison just to keep their autonomy and outrage. We want to simplify our language, our graphics, and our content. But it's very difficult to simplify. Sometimes you're very proud of what you know. It took a long time to learn. And when it's your chance to show off, you don't want it to look easy. Or maybe you would be afraid of being accused of being inaccurate. Simplifying means leaving some stuff out, and your technical peers may see an incomplete explanation as an inaccurate explanation, so it's safer to say it all. We become accustomed to complexifying things. From grade school all the way through professional school, the more complicated sounded explanations get better grades. So it's no wonder we've been trained to make things sound complicated. And then another reason might be that you're just irritated that people are intruding on your turf, and it makes you want to be incomprehensible. At least sometimes burying listeners in too much undigested information can be a way of telling them to butt out. We're hoping you can get over any and all of those constraints and simplify language, graphics, and content. Simplifying your language is not as important as simplifying your content, but it's all important. So let's look at some rules. If the word is there to impress people, cut it out. That's hard to do. But find the examples and phrases you're most proud of and get rid of them. You're not there to impress people. If a word needs defining, define it. Then cut it out. For example, if you're going to say potable water, and then you'll have to tell people what potable water is, just call it drinking water and forget about the term potable water. If you have to teach the jargon, introduce the concept before the words. Sometimes you have to have jargon, so explain the concept, and then say, engineers have a word for this. They call it piping. They call it seepage. But give them the concept first. When tension is high, use less jargon. because anger or fear mean high feelings, and people will be less tolerant of jargon, and the amount of jargon you use often goes up when you're upset. Technical people use jargon for efficiency and insulation. Ask your audience to stop you if you use jargon they do not understand. Stop me quickly when I say it. You should legitimize stopping you immediately. Make it your problem, not theirs. So you can say things like, my training is technical, so if I go off into some jargon, please stop me. I'll back up and say it right. Keep your sentence structure simple. There are high correlations between sentence structure and understanding, persuasiveness, and interest. So keep it simple, short sentences. Avoid nominalization, using nouns where normal people use verbs. If you're talking about cracks in effluent settlement tanks grow faster when there's more stuff in the tank, people understand that. But if you start using nouns instead and invent terms like tank crack growth rate, that would be nominalization. Ask a non-technical person to read what you've written or to listen to you, and ask them to stop you when there is something they do not understand or something uninteresting. Boredom is a real factor. People stop listening when they get lost, but they call it boredom. Warn your audience about difficult material. If there are terms or concepts that are difficult, tell people you're sorry, but now we're getting to the hard part. That's better than just launching into difficult material. Be especially careful about words that have technical meanings that differ from their common meanings. Significance has a statistical meaning that's very different from its normal use. Conservative is another word. Bias would be yet another that would have a technical meaning that's different from its normal use. So be aware of those things. Avoid too much data. Don't make it too small. Don't offer too much information. Make your data readable and make it understandable too. It can help to ask the question you want people to focus on and then answer it with data if possible. Ask and answer a question in ways that people can understand. So here are some hints for how to simplify graphics. When you're dealing with the public, limit yourself to 1 point per graphic. Put the conclusion right on the slide. If it won't fit the slide, then your conclusion is too complex. Use animation to simplify the complex information. Animate the reasoning more so than the data. Focus on bar graphs and pie charts when you can. This is risk communication simplicity. They are more intuitively understandable. Don't use plots that you have to explain. There's no point giving people data you know in advance they're not going to be able to understand. They'll just resent it. Stand in front of the graphic rather than behind it so you can look at it with your audience. A big advantage of graphic material is you get to join people and look at the data with them. Use color to convey meaning, but remember, some people are colorblind. Simplify your content. Stick to your main points. These would be things that either people want to know, things you really want them to know, or things that will be misunderstood down the road. They're the only 3 reasons for explaining something. If your content does not meet one of these 3 reasons, delete it. Something true or interesting or something we worked really hard to find out is not a good enough reason to include it. Provide 3 different levels of complexity, organized like an onion. In technical writing, we use an executive summary, the report, and the appendices. Do the same thing with the public in writing. If you leave out information, people feel a trust problem, But if you give them too much information, they resent that. So there's a balance to strike here. Include only details that are needed to explain your main points or to avoid losing credibility later. That's the test for including a detail. Number one, can they understand the main point without this information? Number two, if they heard the detail later from someone else, would it seem to contradict what you told them? If so, include it. So you might imagine a bad effect that might not be statistically significant. If you leave it out now and someone says it later, you may have to discuss it. If you don't, mistrustful people will find it in the appendix and say, right here in your own report it says, and so even though the detail may not be serious, leaving it out can be serious sometimes. Don't skimp on history, politics, or content. Don't leave out information the audience already knows. So don't skimp on the non-technical details. People may remember the screw-up or the lawsuit in the past, so don't slide over that. If you do, the technical report loses its credibility. Tell people what they already know in language they understand. Let them know you share the history. Tell stories, or at least use concrete language. Stories are better than raw data. Show pictures of your team on the job doing the work. Here we are in the Sound diving into the water to see how many fish died. Stories that demonstrate a specific point are best. A story that doesn't is better than no story. Personalize. If you dare, be a person. We are trained to be impersonal, and we need to overcome that with an audience. Give them a little background. Would you drink the water? I would drink the water, but my wife, she would be drinking bottled water. It empowers the audience to be able to have any position they want to have. Allow your emotions to show, but don't show anger with the public. A useful feeling to express is hurt. Show you're a human and people can be more respectful and understanding. If you act impersonally, you can't blame people for treating you that way. Finally, check for understanding. Watch for glazed over or wandering eyes. Watch for people writing everything down. They're thinking, maybe I'll figure it out later. If you ask people if they understand, they're not likely to say so. So look for the nonverbal cues. When we talk about orientation, we mean telling people where you are and where you're going, using risk comparisons carefully, and being careful not to tell people more than we know. So that means explaining uncertainty and helping them develop the right attitude about uncertainty. These are the topics we'll develop over the next couple slides. Tell people where you're going. Remind people of the structure. Make sure they know where you are in the presentation. We will name 4 things, examine 3 reasons, look at 5 causes, and so on. And then count off the second reason, the third reason. We're used to wallowing in this stuff, but the audience is not. So let them know where you are. There are 3 main purposes here for telling people where you're going. First, we want to make sure the audience knows what every piece of evidence is evidence of. This comes before presenting the evidence itself. They need to know why they need to know it before you give it to them. Second, make sure the audience understands the logic of your argument. The logic or reasoning is more important than the data. If the logic is good, they may better understand the data. Third, you want to keep the audience aware of how much progress is made. It helps the audience to know. So here are some of the things that you can do. Use high-level organizers. A chart with an outline so you can check off where we have been and where we are going is very helpful. Use inductive rather than deductive reasoning. Deductive starts with the data and works its way to the conclusions. Inductive starts with the conclusions and then provides the data to justify them. Deductive reasoning is more persuasive, but it's much harder, and most audiences can't do it. If you start with the conclusion, you need less data. Distinguish major from minor points. Help people see what's truly important. We want to focus on the greatest concerns. Test your technical explanations if you can. Focus groups can be very helpful. Ask them what they learn, and if it's different from what you taught, that's important for you to know. Find out what people already think. What's the current mental model? It helps us know what preconceptions we need to address. People believe a lot of stuff we didn't study because we had no idea they thought those things. Find out what people already think about your topic. Acknowledge preconceptions, especially if you're going to conflict with them. Unless you tell them that's what you're doing and why you're doing it. Use confidence limits, not just in your statistics, but in your language. Keep the concept of confidence limits in our numbers and in our rhetoric. This is what we are absolutely certain of. This is what we think is likely, but is by no means proven. This is what we think is unlikely, but still possible. This is what we'd bet our mortgages on, and so on. Use more reasoning and less evidence. Innumeracy is more common than illiteracy. Even when people are motivated and on the same side, it's important to use more reasoning. Numbers are rough and people expect to have trouble with them, so they often shut down. Part of the answer is to use fewer numbers, more concepts and conclusions, and logical consequences. We don't want too much data and too little reasoning. Use examples, anecdotes, quotations, and risk comparisons. Don't forget non-technical aids to help people understand quantitative data. That last slide got a little long, so let me tease out something and repeat it because it's very important. Learn how to say things like this. Tell people what you know for sure when you are working with quantitative data. Tell them what you think is almost but not quite certain. Tell them what you think is probable. Tell them what you think is a toss-up. Tell them what you think is possible but unlikely. Tell them what you think is almost inconceivable. Notice the words. The words can be helpful in conveying the concepts. Use risk comparisons carefully. This can be the single most useful way to put numbers in context. What does 10 to the minus 6 mean? What is it in practical terms? Even if we understand the number, that doesn't mean we understand what it means. If we say it's bigger than this, but smaller than that, it helps people understand what the number means. The vast majority of comparisons backfire, unfortunately. We just get people angry at us. The worst thing to do is to use two or more unrelated risks where the comparison risk is unrelated to the risk we're trying to explain. Where we often go wrong is the comparison risk involves a different level of outrage. A small outrage and a big risk is no good to compare to a large outrage and small risk. In hazard terms, we might have a good example, but the outrage has to match as well. Driving and skiing are different from living behind a levee. The best comparisons have something in common. If outrage is high, forget risk comparisons entirely, though, and get the outrage under control. Don't make the outrage worse with your comparisons. And some comparisons will make it worse. Some may not make it better, but be careful, don't make it worse. Avoid comparing a high outrage, low hazard risk to a low outrage, high hazard risk. Here are some questions to consider about risk comparisons. Are you really trying to make the size of the risk clear, or are you trying to show up your opponents by making their concerns seem foolish? Always bracket the risk. If you were on the receiving end of the risk comparison for a risk that concerned you, would you find a comparison useful or irritating? Does your comparison seem to be trying to preempt the decision about the acceptability of the risk? Are you acknowledging that it's not a technical decision but a personal one? Is your comparison homey, snide, or slightly humorous? Are you talking about people getting struck by lightning in a snowstorm? Is your comparison likely to seem self-serving? If so, have you acknowledged that you have a stake in convincing people? Do you acknowledge your comparison is self-serving? What's the relationship between you and your audience? How sensitive is the situation, and how cautious do you have to be in choosing a comparison? Do you have a solid, calm, trusting relationship, or will they misunderstand and take offense? When it is sensitive, almost any comparison can backfire. On balance, do you suspect in advance that your audience may reject or resent this comparison? Then why are you using it? Will this backfire? If yes, don't use it. Don't do things you think should work, but know won't work. The audience motivation to understand is your best help, and outrage is what gets in the way of understanding. Explaining data under ideal circumstances is rough. Don't screw it up with a bad comparison. When explaining uncertainty, don't sound more certain than you are. But don't wait to be confronted to deal with uncertainty either. Acknowledge the uncertainty up front. Talk about it before people ask you about it. Don't sound confident and then backtrack. Put bounds on the uncertainty. What range of possibilities is credible? There's a big difference between we know nothing and we know everything. So use error bars or other people's estimates. Put bounds on the level of uncertainty. For accidents, conventional wisdom is don't say anything that might not be true. If you guess wrong and lose credibility, that's a disaster. Don't say you're sure if you're not sure. Of course, some people go too far and say nothing, so we need to look for middle answers. Ways of saying we don't know yet, but it's probably this or this or this, based on what our experts are telling us. Orient people to uncertainty. Clarify that you're more certain about some things than others. Where the problem is, how fast the river's rising. Say what you do know. Explain what you've done or are doing to reduce the uncertainty. What have you learned so far? What more will you learn? How will you learn it? And when will you learn it? If the remaining uncertainty is very small or very difficult to reduce further, say so. Don't overpromise. Maybe it's as close as science can come right now. Once again, learn how to say, we're pretty certain, but we're not going to get much more definite anytime soon. We're rather uncertain now, but soon we'll have answers and we'll know more. We're extremely uncertain and we'll stay extremely uncertain for a long time. That might be the kind of response you have to give with climate change or sea level rise. Explain conservativeness. And watch that word. Conservative means people think we're underestimating and we think we're overestimating. Margins of safety are what you do when you're uncertain. When we estimate a risk, we estimate on the high side. Report everybody's risks, not just your own. Make sure you include the opposition and others. Report a range to avoid outrage. We did our risk assessment and got this. Greenpeace got a lower value, so it's somewhere in there. Convert disagreement to mere uncertainty. Don't hide behind uncertainty. If it's more than likely that the problem is real, despite lingering quality assurance, quality control problems, then say so. Uncertain good news we tend to release and hold back when uncertain bad news, and it should be the opposite. Do not withhold bad news on the grounds that it is uncertain. That's dishonorable, and worse, it's ineffective. Don't perpetuate uncertainty. If there are ways to answer the question that you should be pursuing, say so, and then do those things. Never say there's no evidence of X when you've not done the study that tests for the possibility of X. This is terribly misleading. Sometimes you might stress that finding out for sure may be less important than taking appropriate precautions now. Talk to people in these terms. We don't know if this is a serious problem or not. It would take us $3 million to find out and $200,000 just to stop it. So we're going to just stop it. Acknowledge that people disagree about what to do in the face of uncertainty. Which risks are acceptable and which are not is a values question, not a technical question. Get people involved in reducing uncertainty themselves. The most effective way is to work with concerned publics to find out more. Barefoot science is a scary thing, but can be worthwhile. Get people to help with sampling and inspection. We're finding out together. Don't give too much guidance on what to feel. At times we do that. We give people too much guidance on what to think and feel, and we have to lay off of people's values. Let people decide for themselves what conclusion they're going to reach, and let them decide what value judgments to draw from our data. Technical people love technical explanations, and the public doesn't. If you get too involved in your data, you're no longer talking about dying people. You're talking about numbers, and that makes you very distant to the public. So try to avoid getting extremely technical and distant. Keep appropriate feelings about the data. You need to express appropriate values, or people will disqualify you. Leave the audience free to understand the data and draw the conclusions they want to draw, rather than the conclusion you want them to draw. If people think you're presenting data that requires them to reach the conclusion you want them to reach, their defense is to not understand the data.